Good afternoon, everybody. Hope you had a great lunch, and we're going to get started. So our talk today is about developing a pocket cube emulator, and you'll see it's called 𝗖cie sat. The 𝗖 is stands for an acquire, analyze, and apply. So this is not as much as a technical talk as an educational technical talk. And you see our list of collaborators there. Before we begin, I just want to take a moment, particularly for the young people that are in the room, and I hope there's a lot out there, I can't really see you. I want you to understand that we're standing on the shoulders of giants. This past year, Hal Walker, who was a good friend of mine for the last 10 or 15 years, passed away just about a year ago. And I saw him first speak. And who Hal is, he shot the laser to astronaut Buzz Aldrin in the first one of the first of the 7 science experiments, and that was in the 60s. He just passed away, he was 91, but what got me really liking him was in his talk. I hope some of you recognize what that is, but he says, "We went to the moon on a stick." And that's called a slide rule for the younger generations. No computers, no algorithms, a stick. So you can go ask somebody old. You have to even be older than me to get you to teach you that. I think I learned it in college, and then quickly computers came out. Okay, so
So our work, the 𝗖𝗀 emulator and now the 𝗖𝗀 Pocket Cube, P-Cube simulator has been built on a model that John has used for decades, and a model that I, because I'm smart enough to listen to John, had adopted. It really is kind of a space to earth, earth to space, a SEAS sort of approach. A strong partnership with the NASA GLOBE program. So if you're not familiar with NASA GLOBE, please look that up, globe.gov. But we were able to connect in situ data collection on the surface of the Earth and partner it with satellite imagery. So as John has said, you can teach anything with satellites, and this is a model for how we can do it. Some really important missions that were connected to NASA and NOAA, both Landsat, but then most recently with 𝗖𝑠at and 𝗨𝘀, the 𝗖𝑠at-2 mission attempting to measure the height of every object on the surface of the Earth. We have this back and forth model, and just continues to be a great model for how we connect satellite education to the regular curriculum.
Yeah, and I wanted to add in there too. So the reason, these are not small sats, obviously, but the question here is, like, there's hundreds of people here, young people, and there are thousands of people that work with all of you, as many speakers have spoken about this morning. But there are tens of thousands of students that are in schools that never hear anything about this. And so this point is something that's, teachers in the room will like this. It's free. And those images down the bottom are when you collect data, when the satellites fly over, that comes back to you. So it can introduce you to satellites, and it can introduce you to remote sensing, and it can introduce you to ground observations, putting all those together.
Absolutely. The other piece of this that's important for this work is that it's built on a long-standing commitment to satellite education from the Satellite Educators Association, actually a sponsor of our time together this year. So a nice a level of appreciation for the work that they've done across the time. Founded in 1989. John was one of the initial people on this, so this kind of a mention to this of how long we've attempted to do this kind of work. If you Google the Satellite Education Association, there's a large gallery of lessons that help connect learning about satellites and teaching with satellites, as well as a focus on using satellites for environmental data collection, environmental data analysis.
So the Pocket Cube, which we're going to get to in a second, was based on a CubeSat project, which is a CubeSat, obviously. that students built this, high school students built this, and it's been deployed in many high schools across the country. We did a project with Peru, and this is an emulator. It's not a CubeSat, but here's my caveat to this. This was designed and coded and built by students, not a kit that was assembled. So the learning process went all through that, including the boards. The student that designed this when he was 17, just graduated from college. The person that did all the coding is in his third year at Harvard. So for young people mentoring, these types of things that you're doing right now today, the fact that you're here, help those big school applications.
So one of the things, just to piggyback on what John said about the fact that the 𝗖𝗄Sat was built by students and not from a kit. The other opportunity I think we have is to help students in upper elementary through high school through college understand the role that this design process can take. So it's the old joke about a spherical cow. If you don't know that joke, look it up. It's a physics joke, so I think it's hilarious, but you may not. But the fact that we can take students through and truly understand the processes that go into this design, as opposed to having, I think, what most of us in science education would think of as a black box. So the idea of taking a normal series of experiences that we have typically built into our classroom and then start to drill down and understand the true workings of those things. You know, if the other piece that I think, to John's point about us not teaching about satellites, I think the fact that satellite and data from satellites is just sort of ubiquitous to our daily life. And so lots of students without that understanding don't truly have an appreciation for the role that satellites are playing in their lives. And then most importantly, all of you know this, but the role that satellites can play in their futures. So it's really a nice thing.
Yep. And one other thing too is that, you know, right now it's very popular with young people thinking about going to Mars, because NASA's talking about that all the time. Well, you need to understand, we as educators, none of you are going to be going to Mars. Right now, the first people that make it to Mars, assuming we make it there, are in about second grade. So how do we start teaching people how to prepare for that? Because this is not taught in schools, as most of you know. So somebody has to do it, you're doing it. Okay, so as we move into this is reasons. I'm not going to read that. You can read it yourself. But one of the reasons for starting the PocketQube emulator was, again, to address these issues, give students the direct ability and the authenticity to work through the problems and come up with a product. And, you know, as a teacher or former teacher, well, I still teach, but I was teaching in the classroom, that you get to see them build successes and move on into areas that they never hold. These students that I taught with this never knew what a CubeSat was. And yet it took them about 2 or 3 weeks to start building one. So to the PocketQube emulator, our latest project, we're still, to be truthful, we're about 99% there, but we're pretty good, maybe 99.9%. But it's an emulator. We want to make that clear. So the part of an emulator is that we want to emulate or show students what it takes to build a PocketQube. So if you're here talking to Alba Orbiter, then you can buy that. The thing is that these are very inexpensive and affordable by students or teachers or clubs. Here's the components that are inside. They're all off-the-shelf technology, and assembling them, they're the components. I should also say Dr. Jim King, who many of you might know with the U.S. Naval Academy. He and I have also been friends, like Kevin and I, for about 15 years. And so he's the lead engineer on that. And so we're working with the midshipmen at the Naval Academy, building these as well and experimenting with them. This is my latest youngest student. He's a senior in high school. He's not an engineer, but he's a coder. So I know a lot of young people like code. So he's writing a code. I should brag on him a little bit. He won a Congressional App Challenge contest about 2 years ago. And so he's into writing programs. So I asked him to develop something that would be like a flight predictor, what it says, and get him to see, so we can simulate where these will go. And there's going to be parameters that can be changed in there so that students can see if you change wind direction, speeds, altitudes, how the projection would go. And you see the graphic here of the Pocket Cube emulator with a balloon. Our intention is not high altitude balloons like most of you probably do, but just to get like I call it the dollar store balloon, party balloon. And the one things with the Pocket Cubes, they're light enough for maybe 1, 2, or 3 at the most is enough to do that with a tethered balloon. Now, if you don't know anything about teachers, particularly when you get into like middle school, sometimes you'll find the students know or quicker to jump to this stuff than the teachers. But we wanted to do something that could be done in every classroom across the country to introduce people to look at the data, look at how it's collection. And my goal is that then, they grow up to be one of you that are here, young people that are here today, and you're working with all of your advisors and people like Kevin. So that's it. This is what it looks like. This is the real picture of it. That's how you get. And so the Satellite Education Association that Mike mentioned back in the early slide, we've been around for 38 years. And the beginning of that was started by a teacher who read an article about building an antenna to capture direct readout data from NOAA satellites. And at that time, we didn't even know if it was legal to download stuff off the satellites. And that got NOAA and NASA's attention. And for probably most of you in the room, we're not alive or at least aware of what was going on in 1989. So I remind you, that was pre-computers in the classroom, definitely no internet. And so we spent our first years trying to solve those problems. And now I get to stand in front of all you and watch all the wonderful things you do. So with that, we'll end. Thank you very much for attending. And I don't know if we have time for questions, but I'll be around today and tomorrow, and you can grab us.
Yeah, the other thing I was going to say, I mentioned the fact about the sort of that process. I'll just leave a folder on this first share that shows the open source software that we're using in our work, kind of upper elementary through high school in our direct work. Please just take a copy if you're interested.